Welcome to the Introduction to Cloud Security. This course introduces IT security and the challenges it brings, as well as what changes are required moving to a cloud model. In addition, real-world cloud security solutions will be discussed. This is the story of Infoman, the masked superhero and his trusty sidekick, Binary Boy. Together, they are out to fight the forces of data abuse wherever it may be. If data is being used for evil, Infoman and Binary Boy will be there to fight for confidentiality, integrity, availability, and the information way. Infoman has a problem. Data is expanding faster than he can keep up with in his private data cave and needs to expand to a hybrid or public cloud model. However, Infoman wants to keep his identity safe and fears that if he moved his data to the cloud, it would be revealed forever. We will find out that with the help of his always knowledgeable butler, Alfred Dataworth, he will find out how to keep his secret safe.
Binary Boy, now that we have some time in between fighting cybercrime, we need to figure out how to deal with all this big data. Our info cave is just not large enough to handle it all.
Holy Hadoop, Infoman! How do we keep up?
There seems to be only one way, Binary Boy. We need to look at the cloud and expand.
Well, gee, Infoman, that should be easy. Let's go to a public cloud provider and sign up. I can use my trusty superhero credit card on my utility belt. Many industry verticals like finance, retail, and the public sector are using the cloud. Why not use it in the fight against evil? The cloud has many advantages.
You're right, Binary Boy, but not all is well in San Binaria. There are security concerns. If we put our data into the cloud, our personal identities could be uncovered, and then the villains will know who we are. How can we trust the cloud? Thankfully, our butler, Alfred Dataworth, is a CISSP, or Certified Information Systems Security Professional. I know that's a mouthful, but that means he's a security geek. Maybe he can help us solve this problem. I'll call him on the info phone.
Good idea, Infoman.
Alfred, how do we know we can trust the cloud?
I would be happy to help, sir. Before we talk about the cloud, I would like to speak about the fundamentals of IT security, if I may. IT security, simply put, consists of three principles. It has to do with confidentiality, integrity, and availability, or CIA for short. All three principles are used to protect and secure IT services, and of course, the data itself.
Holy G-Man, Alfred did some work for the CIA. How coincidental.
Correct, Binary Boy. Now, the CIA triad contains the key values in any kind of secure system and is applicable across any data center or cloud model. If any one of these three is breached, serious consequences may result. Sir, if I may, let me explain confidentiality, integrity, and availability one at a time. Confidentiality is the ability to hide information from those unauthorized to view it. Cryptography and encryption methods are examples of approaches that attempt to ensure confidentiality of both data that is transferring from one data cave to another, also known as in-flight data, as well as static data or data at rest. The second principle is integrity. Integrity is the ability to ensure that data is an accurate and unchanged state compared to its original secure data source. One type of security attack is to intercept important data and make changes to it before sending it to the intended receiver. As you know, the villainous Dr. Data Breach is very good at that. You also might have heard that this type of attack is referred to as man-in-the-middle and phishing, among other terms. The final principle in the CIA triad is that of availability. The concept of availability ensures that the information is readily accessible to the authorized viewer at all times. Some types of security attacks attempt to deny access to the appropriate user, either for the sake of disrupting them, or because there is some secondary effect, such as trying to gain access. This is often called a denial of service attack. For example, in his greedy quest for power, Dr. Data Breach might breach or break our Infoman website index by a particular search engine pointing to his own website. Similarly, when many villains act together to deny access to information, it is called a distributed denial of service attack.
Thanks, Alfred. Now that we know the basics about IT security, what do we need to know about moving from the private data cave to a public or hybrid cloud?
As shown, sir, there are many similarities to security between our own private data cave and public clouds, from compliance, governance, disaster recovery, availability, identity, and of course, data security. All of these are important, but when you are talking about moving our identity of our data out of the data cave and into the cloud, you have to address information residency apprehensions, and that drives data security.
Holy data info, man. You weren't kidding about your fears of losing our data confidentiality. It's all about the data.
Correct, Binary Boy. My suspicions are never wrong. Continue, Alfred. Let's hear more about data residency concerns driving data security.
Data residency refers to who manages and who has access to the data, where the data is stored, and what laws apply. In addition, how do we know when data is stolen? Finally, when we end our relationship with a cloud provider, how do we know if the data is deleted? Similar to superheroes, enterprises must adhere to a complex array of privacy laws in the jurisdictions they reside or the location or country their cloud provider operates in. For example, when you travel to another country, you are governed by laws of that country. This is also true of your data. Cloud computing blurs the lines of country borders. Therefore, it's very important to understand where your data physically resides. If our info cave is in the United States, but our servers are in the UK, and the data is in Australia, current international laws state that the location of your data is the only thing that matters. The location of the servers, networks, and users are unimportant. There is also a need to create automated and auditable ways to erase data in the cloud. There are always questions as to if and when the data is really deleted. The other question is, how do you know when and if your data is stolen? One way to address this is for the cloud provider to offer historical data logs. This will provide security forensics to determine if and when a data breach has occurred.
Got it, Alfred. So many issues and so little time. What then are the additional tools we need to add to our utility belts to address the data residency security problem?
Sir, tokenization and data encryption are the two primary ways to address data residency complications.
Holy technology mumbo-jumbo, info, man. I must have slept through my superhero cybersecurity class. What does all that mean?
Fortunately, Binary Boy, in between fighting villains, I did open up a book or two. Alfred, let me take it from here.
Most certainly, sir.
Let's take an example of a hybrid cloud solution. Data encryption is the mathematical process of converting data that anyone with access can read, also known as clear text data, into ciphertext data. Ciphertext data cannot be read by anyone other than the custodian or customer who has or owns the encryption key. Anyone who has the key can access the data. So, we would maintain our keys in our info cave or private cloud and encrypt our data to the public cloud.
But info, man, what if the key gets lost or stolen by some dastardly villains? Plus, if they have enough brain or CPU power and enough time, Can't they decode the key and gain access to our identities?
True, Binary Boy. Our data in the public cloud would still be reversible back to our original identities if they had the key and algorithm. Any form of encryption has its roots to the original data. You can try and hide, but the data in the cloud is based on the original data. In addition, encryption methods have other challenges such as key management. The second solution is tokenization. Tokenization is the process of keeping some data local in a database and using this random data, or tokens, as a reference to the real data. These tokens are associated with data sent to the cloud, but have links to the actual data they represent. As a result, the data can only be read by the custodian of the database. Think of the data being sent to the cloud as a ghost. The ghost in no way represents the original data. The only way you can find out who the ghost really is by using the local database and keeping the contents in a place you know is secure. If the database is kept safe in our info cave or private cloud, the evil villains cannot in any way, shape, or form trace our identity no matter where it is.
Holy Halloween, Info Man! That sounds great. Why then do we have two solutions? Shouldn't tokenization solve all of our problems?
That's a good question, Binary Boy. Our butler should have the answer. Alfred?
Sir, both tokenization and data encryption have their advantages and disadvantages. Tokenization only protects from external threats. For example, if someone from within our info cave or private cloud has access to the database, they will see our identity. On the other hand, encryption protects from both internal and external threats. For encryption, we just need to make sure we have policies enforcing what we call segregation of duties, which means making sure the person who has the keys does not also have access to the data itself. As for storage, tokenization requires higher powered servers and databases that require more management, with increasing data volumes than encryption. As a result, tokenization does not scale easily with increasing data capacity requirements, as well as encryption does. In comparison, encryption requires lightweight stateless servers with little or no storage requirements.
That's great, Alfred. Are there any solutions out there that can do both?
Yes, sir. RSA, one of EMC's Federation of Companies, focuses on security and provides the perfect answer. It's called RSA Data Protection Manager. It delivers both tokenization functionality as well as industry-leading encryption at both the application and data at rest levels.
That's great, Alfred. Thanks for bringing this solution to light.
You're more than welcome, sir.
Holy real-world solution. What do we do now?
It's time to take action, Binary Boy. Now that we know what the cloud can offer us and how to be safe up there, we should take the lead. The first step is to embrace the traditional IT security approaches outlined by the CIA triad of confidentiality, integrity, and availability, which includes identity management, role-based access, compliance, and service integrity. Next, we address the cloud data residency issues through encryption and tokenization. Finally, if we embrace the best-of-breed solutions offered by companies like RSA, how can we lose?
Holy cloud security, Info Man. Watch out, would-be evildoers. We're on the case.
Right, Binary Boy. Our identities will be safe forever.